Hello and welcome to this video in which we shall continue with graphing exponential and log functions. So we're required to graph this function here, f of x equals log base 3, x minus 2 minus 2 on the axes below. You must plot the asymptote and any 2 points with integer coordinates. So if you have a calculator, you can just plug this equation into the calculator, get a table of values and substitute. However, I'm going to attempt to solve this without a calculator here for your benefit. So what are the significant values of log? So we should know that log 0 gives us infinity or math error. Log 1 gives us 0. These are the two main significant values. And then other values depend on this base. Why is that? So because log base 3 of 3, for example, equals 1. Log base 3 of 3 power 2, you can just kick out the power. So this gives us 2. And log base 3 of 3 power 2 is the same as log 9, 3. So this gives us 2. Now log 3 power 3 base 3 gives us 3 because we just kick out the power here. And this tells us that log 27 base 3 gives us 3. So the interesting values when we have a base of 3 would be 3 and 9 and 27. So log 3 base 3 is 1. Log 9 base 3 is 2. We don't even need more than that because we just need 2 points anyway, so it doesn't really matter. So we use a table of values and we want to figure out when x minus 2 is going to give us the interesting values. So we want x minus 2 equals 0, x minus 2 equals 1, x minus 2 equals 3, and x minus 2 equals 9. So in this case, x equals 2, because we take the 2 to the other side. Here, if we take 2 to the other side, we get x equals 3. We take 2 here, we get x equals 5. And we take 2 here, we get x equals 11. So the interesting values for x are 2, 3, and 5, and 11. Now, let's figure out what happens to the y in each of these cases. So x and y. So for 2, we get 2 minus 2, which is 0, so y becomes infinity. For 3, we get log base 3, 3 minus 2 minus 2. So 3 minus 2 is 1, and log 1 is 0. So 0, all of this here is 0. 0 minus 2 gives us negative 2. And then the next interesting value is 5. Now, if we put log base 3, 5 minus 2, I'm sorry, I missed the negative 2 here as well. So minus 2 here. So 5 minus 2 gives us 3. Log 3 base 3 gives us 1. So this whole thing is just 1. 1 minus 2 gives us negative 1. So we can just use this table to graph the function. Let me just clear a bit of the workout so that we can graph. Okay, so we have 3 possible values here. So for the 2, we have infinity, so that's where the vertical asymptote is. So I'm just going to put the vertical asymptote at 2. For 3, I'm going to put negative 2, so 3 and negative 2, which is here. And 5 and negative 1, so 5 goes with negative 1. And we have the graph. Let me recap. I wanted just to get interesting values out of x minus 2. So I equated it to 0 because we know that log 0 is infinity. I equated it to 1 because log 1 is 0. And then I just equated to any powers of 3 because we have a base of 3 here. So we try 3, 9, and so on and so forth. We actually only needed the 3 here. So you just equate it to 3, equate it to the base, and then you're all set. So this wraps up this problem here. We can submit. Let's try another one. So again, the interesting values for logs are log 0 is infinity, log 1 is 0. And in our case here, we just want to equate to log 2 base 2. So we want to get log 2 base 2 because this gives us 1. So we want to equate the expression inside the log to these three values here. So we have x plus 1 equals 0, x plus 1 equals 1, and x plus 2 equals, x plus 1 again equals 2. Now for each of these, we get the x. So here x is negative 1, x is 0, x is 1, positive 1. Now we can figure out the y in each case. So we have x and y. So when x is negative 1, we can plug into this equation. So we have negative 3 log base 2, negative 1 plus 1. Obviously, this is log 0, and this is just vertical asymptote. So this is infinity. When x is 0, let's plug and see what happens. So we have negative 3 log base 2, 0 plus 1 plus 2. And 0 plus 1 is just 1. And so log 1 is 0. So this entire expression here is 0. And we have plus 2. So we're going to just write 0 and 2. And then for the third case, we're going to put negative 3 log base 2. And then we're going to plug 2 for x. We're going to plug 1 for x. We're going to plug this value here. So 1 plus 1 plus 2. Now, 1 plus 1 is 2. And log 2 base 2, this part alone is just 1. So negative 3 times 1 is negative 3. And we add 2, we get negative 1. So when x is 1, y is negative 1. Now we plot these onto the graph. So the vertical asymptote is at negative 1. And when x is 0, y is 2. So this goes here. When x is 1, y is negative 1. So this goes over there. And we just submit. Let's try a third problem. Here we have log base 3 x minus 2. Again, so we want the x minus 2 to be equal to three interesting values, which are 0, 1, and 3. In this case, 3, because 3 is the base. So for each of these, here x is 2, here x is 3, and here x is 5. So we have a table, x and y. X is 2, 3, and 5. We plot, we substitute, in the equation. So for x is 2, we have log base 3, 2 minus 2, which is infinity, because log 0 is math error or infinity. And if we put 3, we get log base 3, 3 minus 2, which is just log 1, and this is 0. So we put 0 here. Finally, for the 5, we have log base 3, 5 minus 2. This is 3. Log 3 base 3 is 1. So this is 1. So we have a vertical asymptote. And we go to the 2 like this. And then 3 and 0. We just drag this to 3, 0. And then finally 5 and 1. So you just drag the other point to 5 and 1. And you're done. And that's it. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.